Hello, this is day 3 for normal calculations using normal CDF application in the calculator for Mrs. Sorrentino and Mr. Kenzie's Algebra 2 classes. Number 1, two graphs of normal density curves are shown to the right. Which normal density curve, the solid curve or the dash curve, represents the distribution with the larger mean? How do you know? Well, if I take a look at these pictures, they both are symmetric, are bell shapes. However, the dashed line, the middle curve, is 30, and when you have a normal distribution, the middle is the mean. So therefore, that would have the larger, higher center, if you will. B, what normal density curve represents a distribution with a larger standard deviation? Standard deviation is spread. So the solid curve is more spread out. It goes from 10 to 40. Number 2, the distribution of the height of 6-year-old girls is approximately normal with a mean of 115 centimeters and a standard deviation of 4 centimeters. Sketch a normal curve that represents the height of 6-year-old girls. Be sure to add appropriate scaling for horizontal axis, including specific heights, and mark the mean, and then +1 standard deviation +1 and -1 standard deviation, plus and -2 and plus and -3. So if you take a look, 115 goes in the middle. From the right, we add 4, continuing to do that 3 times, then subtract 4 to the left. So the nearest percent, what percent of 6-year-old girls are between 119 and 127 centimeters tall? Shade this region on the diagram. So we're going to use our calculator using second and VARs to get normal CDF for normal distribution. Our lowest value is 119. The largest is 127 because it's in between those two. We then type in the mean and the standard deviation. We plug this in the calculator and we should get about 16%. Now the next few, we are going to be using normal CDF. And as you can tell, I have each of the numbers that were plugged in. So greater than 16. So greater than 16, I have 16 as the lowest. And then I went all the way up to 10,000. You can go larger than that if you would prefer. Then I have the mean of 16.6 to get about 50%. For B, I did the same thing, except I changed the lower and the upper to get 68.3%. For C, for this one, I did greater than 28. So 28 and then higher. So I did, once again, 10,000. And I got 2.3%. For D, for this one, less than 1. So for this, I just did the lowest value of -100 to 1. Now, we know that for heights, you're not going to have a negative, but we want to go further than what we think is realistic. Then we have 16.6, so about 0.6%. For each of these, we're getting a decimal and multiplying times 100. For E, we have 66.9%, and then for F, 15.2%. For 4, the weights of Siamese cats are normally distributed with a mean of 6.4 pounds and a standard deviation of 0.8 pounds. If a breeder of a Siamese cat has 128 in his care, how many can he expect to have weights between 5.2 and 7.6 pounds? So we're using normal CDF again. The lowest value is 5.2. The largest is 7.6. We then type in the mean and the standard deviation. We multiply by 128 after we get our decimal because that's how many cats there were. Taking a look at the next. Now this is, once again, is a lot of the normal CDF. So for this one, the answer, once you get your decimal, you multiply times 100. We multiply times 100 because that is out of, to convert to a percent. Also moving the decimal spots 2 places to the right can do that. So 2.3%. Number 6, we got a decimal, so I went from 0, 31, 84, 4. You can also type in -100 instead of 0, and I'll get you the same answer. I got 0.668. I multiplied that times 31, because there were 31 days in July, to get 2.07, so about 2. About 2 days in July, a person can expect to have temperatures above 90 degrees. Number 7, now if you take a look, I did all these on the choices, so that's the 99th percentile, 96th percentile, The last one is 78th. We were looking for the 90th percentile. So plugging in, I did negative 100, 43, 38, and 3.9 to get the 90th percentile, which was choice 3. Number 8. Number 8, I use this, and I drew a chart. It says, then what is the standard deviation? Well, it gave us the mean, and it gave us the distance for 68%. Well, 68%, as we know from our lesson, that covers one standard deviation above and below. That's 68% of the data. All right, that is near the middle. So I just found the distance between each of those, which would have been 16. Number 9. Okay, for this one, I first converted it to inches. We're looking for 2.3%. As the heights of professional basketball players are normally distributed with a standard deviation of 5 inches. If only 2.3% of all pro basketball players have heights above, then which of the following? So now for this, my middle, all right, I have 7 feet 5 inches, and then I subtracted 5 and went over. Now 7 feet, this represents one standard deviation above. I knew that this was the second standard deviation because 2.3%. 2.3% is to the right of the second standard deviation, also to the left of the second standard deviation when you're subtracting. So therefore I would have also could have used 89, all right, for my lowest, because 89, all right, when it comes to inches. The largest, which is, I put at 999. Now we know that's not realistic. We want to go further than what we think is real. 79 for our mean, standard deviation of 5. So you can also use this to get an answer of choice 4, which is 6 feet 7 inches. I just did it once again by thinking and knowing that 2.3 was to the right of the second standard deviation. Number 10, on a recent statewide math test, the raw score average was 56 points with a standard deviation of 18. If the scores were normally distributed and 24,000 students took the test, answer the following questions. A, if the state would like to scale the test so that 90% would correspond to a raw score, that is 1.5 standard deviations. So the first thing I did is I drew a picture. All right, above the mean, the raw score needs to be for 90%. So you can also just take 56, multiply by 1.5 times 18. The reason why we did that is 1.5 is the standard deviation, all right? Or 1.5 standard deviations above and times 18, which was the standard deviation, to get 83. Now I knew that this was going up. Standard deviation 18 and half of 18 is 9, so I went up by 9 to get 83 that way. B, how many of the 24,000 students received a scaled score greater than 90%? So for this, greater than 90%. Now we know this is 83. Now I did 200. You could have done 2,000, just a number that is very large. Then I have my mean and my standard deviation to get 0.066. I multiplied by 24,000 because that's how many students there were that took the test. Question C. The state would like no more than 600 of the 24,000 students to fail the exam. What percent of the total does the 600 represent? So 600 over, I got some marker on this, so 600 over 24,000 times 100 to get 2.5%. Then it said, what should the raw passing score be set at? To the nearest whole number, so that less than 600 students fail. So 2.3%. All right, because 20 and less than that, all right, which that would be one standard deviation below, 2 below. And by definition, it's about 2.3% below that. Thank you.